Hi, I'm Dave from TRC. Welcome to our Heat Pump Boss series, Level Up Your Heat Pump Installs. We've got the tools, tips, and how-tos that will help make you an expert heat pump installer. Today, we're going to focus on existing duct management. Let's dive right in. Duct sizing is one of the most critical factors to getting the most out of a heat pump. Even a perfectly sized heat pump can't perform efficiently if the ducts aren't sized correctly. Duct sizing directly impacts two key aspects of system performance: airflow and static pressure. First, let's talk about airflow. Airflow is all about whether the duct system can deliver the required cubic feet per minute, or CFM, to the spaces that need it. If the ducts are too small, they restrict airflow, making it difficult for the system to push air to the rooms that need it. On the other hand, oversized ducts can cause balancing issues, leading to uneven air distribution. Both scenarios result in comfort issues, with rooms running too hot or too cold, and the system struggling to keep up. Next, static pressure. Static pressure measures how restrictive the duct system is to the movement of air. Undersized trunks, bad transitions, restrictive filters, and long duct runs can all increase static pressure. When static pressure rises, the delivered airflow drops, forcing the fan to work harder and reducing the system's efficiency. This is why duct sizing is so important. It's not just about matching the heat pump to the home. It's about ensuring the ducts are sized with the same care. Properly sized ducts allow the system to operate efficiently, maintain consistent temperatures, and deliver comfort the homeowner expects. Duct sizing isn't an afterthought. It's a fundamental part of the load calculation and overall system design. Now let's look at the rest of the picture. How are the ducts physically laid out, and what condition are they in? Let's start with the layout and distribution. A heat pump needs a distribution system that delivers air where the load is. That means being mindful of long, winding duct runs. Long runs can result in decreased airflow and negatively impact distribution of conditioned air. The condition of the duct's insulation matters. Ducts often live in attics, crawl spaces, or unconditioned basements. If the ducts aren't sealed and insulated well, or if the insulation is falling apart, you're losing capacity before the air even gets to the space you wish to condition. Leaving the ducts exposed to unconditioned air can result in comfort issues, both during heating and cooling seasons. On a similar note of condition, it's important to remember ducts are moving the air we are breathing, so be aware of their internal cleanliness as well as their structural integrity, and make sure to notify the homeowner of any concerns in either of these areas, especially if you will be reusing existing runs. Now that we know what matters, we can talk about assessing ducts. But first, you have to find them. Ducts are most often located in the attic, basement, or crawl space of the home. They are typically fairly obvious and accessible, but in some instances, they might be buried in the insulation or hidden in floor or wall cavities. Once you have located and have access to evaluate ductwork, you should account for the following conditions before deciding on your approach. Asking a homeowner when their ducts were installed and the last time they were cleaned will give you a starting point on what to expect. The age of ductwork will help to reveal potentials for leaks, reduced efficiency, impacts to indoor air quality if a more in-depth assessment needs to be performed, and possible buildup of dust and dirt. Next, consider whether the ductwork was originally sized for heating or cooling. If it was sized for heating and is relatively new, it might be possible to reuse with some modifications for a heat pump system. If it was sized for cooling, it could be undersized and may require additional work to meet the demand of a heat pump. Finally, assess the condition of the ductwork. Is it in good shape and properly sealed and insulated? You want to install a heat pump that can provide the right amount of heating and cooling to the building, so you don't want to undermine performance by losing a large portion of that energy into attics, crawl spaces, or basements through leaks and bad duct insulation. These questions can help guide your assessment and ultimately inform your decision to retrofit the duct system or not. Now, let's say you've assessed the ducts and deemed it necessary to retrofit or upgrade the ducts for a heat pump. There's more than one way to approach it, but not all practices guarantee optimal long-term performance. We're going to discuss a range of options for duct retrofits, some okay, some good, and what's best practice. The more you adhere to best practice, the easier it is for the heat pump to deliver the comfort and performance it's designed for. Best practice usually means better airflow, lower static pressure, quieter operation, and fewer crawlbacks. It's the path that makes the equipment function well and keeps the homeowner happy. Let's begin with the good practices for assessing and retrofitting ducts. These practices are the bare minimum you would want to follow to expect performance even approaching design capacity. Start by talking to the homeowner. Get a sense for their comfort, noises, mustiness, or annoying airflow issues. This will help guide your physical and visual assessment. It's important to check for asbestos potential, recent modifications, and their habits of filter replacement. Next, visually inspect accessible ducts. Look for bends, compressions, disconnections, discolorization of insulation, joist panning, which is very leaky, and awkward restrictions to cross-sectional areas, like riser chases between floors. You might also notice oddities like grills or registers being taped shut or blocked by furniture. Pay close attention to anything that might be causing the homeowner discomfort. Once you've completed the visual inspection, do the math on any sections that look tight, has lots of bends, or are known to have comfort issues with the existing furnace. Compare duct trunk and branch capacities to your airflow requirements from Manual S. Use National Comfort Institute standardized duct sizing tables to guide your calculations. If you find any parts of the ductwork that are insufficient, or if the whole system needs to be scrapped, plan out new ducts. If you're going with the new ducts, consider whether a blended system of ductless, ducted, or short static systems might work better than a whole home ducted system. Finally, perform non-diagnostic commissioning. Once you're confident the duct system will work, or you've adapted some element to make it work, install the heat pump and fire up the system at full fan power. Confirm that airflow is reaching all the registers, and check for any signs of obvious leakage into the attic, crawl space, or basement. Now let's move on to the next level, better practices for duct retrofitting. Everything from the good steps still applies, but now we're adding diagnostic tests to ensure the system performs better. Start by performing a total static pressure test, or TESP. This test measures how restrictive the duct system is and ensures the results are within the limits of the heat pump and air handler. You can test the system as is during the assessment phase, and you should also test it again during commissioning. While we won't teach the full protocol for TESP in this video, it's important to understand its value in diagnosing duct performance. Next, verify duct balancing. Similar to TESP, you can perform this test on the system as is during the assessment phase, but it's essential to do it during commissioning. Proper duct balancing ensures airflow is distributed evenly throughout the home, preventing hot or cold spots. Finally, measure airflow at the registers using a flow hood. This step confirms that the airflow meets Manual S requirements. Like the previous tests, airflow measurements can be used as both diagnostic tool during assessment and as part of commissioning after changes have been made. Now let's cover the best practices for duct retrofitting. At this level, you're doing everything from the previous steps, but you're also taking additional measures to ensure the system performs at its absolute best. Start by completing a full Manual D process to determine the duct design for the house. If you're thinking of repurposing parts of the existing duct system, roll that into your design and carefully evaluate what needs to change. Manual D helps to ensure that the duct system is optimized for the home's specific needs, delivering consistent comfort and efficiency. Next, perform a full duct leakage test using a duct blaster and blower door with a pressure pan. This test identifies leaks in the duct system and quantifies how much air is being lost. By addressing these leaks, you can significantly improve the system's performance and prevent energy loss. These best practices ensure the heat pump can deliver the comfort and performance it's designed for, while minimizing callbacks and keeping the homeowner happy. In this example, we'll see why duct management is important. This 2,200 square foot condo in the Hudson Valley reused existing ducts from a prior natural gas furnace. But the homeowner complained about room temperatures. With the thermostat set to 66 degrees Fahrenheit, one room was too hot at 73 degrees Fahrenheit, while the other was too cold at 59 degrees Fahrenheit. So what's the issue? The signed contract required furnishing and installing new insulated ductwork, but the contractor only installed a new duct trunk and reconnected the existing room runs. A little digging found the front room, which was hot, had a 6-inch duct running short and straight to that room. The back room, which was cold, had a 6-inch duct, but it meandered with multiple turns and had a partly crust section going over a joist. To make matters worse, a third duct run continued to get disconnected and had been reattached several times already. Chronic issues undercut any other improvements being made. These issues highlight the importance of properly evaluating and addressing ductwork prior to installation. Uneven duct runs, crushed sections, and poor connections can lead to significant comfort issues and inefficiencies in the system. For more information, visit Clean Heat Connect's Cold Climate Duct Evaluation Guide. A link will be provided in the video's description. Within this guide is information regarding the importance of duct sizing, National Comfort Institute's standardized duct sizing, and a deeper understanding of testing ductwork. For an even deeper understanding, review the Managing Existing Ductwork training on cleanheattraining.com. Thanks for diving in with us on Existing Duct Management. Remember, we're here for you at cleanheatconnect.ny.gov with more videos, resources, guides, and best practices. Hope to see you in our other sessions as we complete better installations together, one project at a time.